The ocean has a remarkable way of keeping its secrets. For more than 7 decades, one of the most famous ships ever built rested somewhere beneath the North Atlantic, hidden so completely that no human being could point to its exact location. Everyone knew the story of the Titanic. Millions could describe the night it disappeared beneath the waves in April of 1912. Yet for 73 years, the ship itself remained beyond reach, swallowed by darkness, pressure, and nearly 2.5 miles of water. It is difficult to imagine today, when satellites map the planet in extraordinary detail and underwater vehicles can explore places once thought impossible to reach, but there was a time when finding the Titanic seemed less like a scientific challenge and more like chasing a legend. Every year that passed made the mystery even greater. The wreck was not simply lost. It had become part of the imagination of the world. Historians searched old records. Engineers studied navigation charts. Oceanographers calculated currents and drift patterns. Explorers proposed one theory after another. Newspapers occasionally reported fresh attempts, each carrying the hope that history's most famous missing ship might finally be found. Yet expedition after expedition returned with nothing but unanswered questions. The Atlantic remained silent. What made the mystery even more remarkable was its scale. The Titanic was nearly 900 feet long, one of the largest moving objects ever built in its time. Common sense suggested that something so enormous should eventually be discovered. But the ocean does not follow common sense. It follows its own rules. Beneath the surface lies a world almost completely disconnected from sunlight, where freezing temperatures, crushing pressure, and endless darkness conceal landscapes more remote than many places on the moon. The deeper scientists looked into the problem, the more they realized that the greatest obstacle was not locating a ship. It was understanding an environment that humanity had barely begun to explore. As years turned into decades, the missing liner became something larger than a maritime disaster. It became a symbol of humanity's limited knowledge of the deep ocean. Every failed expedition reminded researchers how little was truly known about the seafloor. Every unsuccessful search raised new doubts about the assumptions people had accepted for years. Had investigators misunderstood the sinking? Were the recorded coordinates inaccurate? Had ocean currents scattered the remains far beyond the expected search area? Or was the wreck simply resting in a place no existing technology could reach? These questions transformed the search into far more than an effort to recover a historical site. It became a test of scientific persistence, engineering innovation, and human curiosity itself. Yet perhaps the greatest irony of all was this. The world believed the mystery centered on the Titanic. In reality, the greater mystery was the ocean. Until explorers learned how to search an environment almost entirely unknown to science, the ship would remain hidden no matter how famous it had become. That realization would eventually change everything, because solving the mystery of the Titanic would first require solving the mystery of the deep sea itself. And that breakthrough would arrive only when someone dared to stop searching for the ship in the way everyone else had before. To understand why the search lasted so long, we have to leave the history books for a moment and descend into the environment where the answers were waiting. The challenge was never measured only in miles across the Atlantic. It was measured in depth. The Titanic rests nearly 2.5 miles below the ocean's surface, more than 12,000 feet beneath the waves, in a place where sunlight has never reached. At that depth, the world changes completely. Temperatures remain just above freezing throughout the year. Absolute darkness surrounds everything in every direction. The pressure is so immense that every square inch experiences several thousand pounds of force, enough to crush equipment never designed for such conditions. Long before explorers could hope to find a single ship, they first had to solve the much greater problem of simply surviving in that environment. During the decades following the disaster, the technology required for deep ocean exploration barely existed. Sonar was still evolving, underwater imaging remained limited, and remotely operated vehicles capable of exploring the deepest parts of the ocean were only beginning to emerge. Modern audiences often assumed that locating a ship should have been as straightforward as scanning the seafloor, but that assumption overlooks the enormous scale of the search area. The North Atlantic is vast beyond ordinary imagination. Even if investigators narrowed the location to a relatively small section of ocean, they were still facing hundreds of square miles of rugged underwater terrain, hidden beneath nearly 2.5 miles of water. Searching that landscape was like attempting to locate a single building in complete darkness while flying thousands of feet above a mountain range. Every hour of exploration required extraordinary precision, immense financial resources, and equipment operating at the very limits of engineering. There was another complication that few people considered. Many early search efforts were built upon assumptions about how a large ship would behave after sinking. Researchers expected to discover a single wreck resting close to the reported position. That expectation shaped search strategies for years. Yet assumptions can become obstacles when they remain untested. Ocean currents, underwater topography, navigation errors, and the unknown behavior of debris during the sinking all introduced uncertainties that expanded the search far beyond what anyone originally expected. The deeper scientists examined the problem, the more they realized they were confronting questions that extended beyond the Titanic itself. They were learning how little humanity understood about the deep ocean. Every unsuccessful expedition produced valuable scientific knowledge, even when it failed to locate the ship. New sonar systems improved underwater mapping. Better navigation techniques reduced search errors. Advances in deep-sea engineering gradually allowed researchers to remain underwater longer and observe more of the seafloor than ever before. In an unexpected way, every failure brought explorers one step closer to success because each attempt revealed another limitation that could eventually be overcome. The search was quietly transforming from a maritime investigation into one of the most ambitious scientific challenges of its time. By the early 1980s, technology had advanced farther than many experts had once believed possible, but one essential question remained unanswered. Even with better equipment and decades of accumulated knowledge, where should explorers actually begin looking? The answer would not come from searching harder. It would come from abandoning the assumptions that had guided nearly every expedition before and replacing them with an entirely different way of thinking about how lost ships leave their final traces across the ocean floor. By the beginning of the 1980s, the search had reached a frustrating crossroads. Decades of determination had produced impressive advances in ocean science, yet the ship remained invisible. It was not because people had stopped looking. If anything, interest had only grown stronger. Governments, research institutions, private organizations, and experienced explorers all understood the historical importance of the mission. What they lacked was not motivation but a reliable strategy. Most expeditions still followed the same basic assumption. They believed the wreck should be resting close to the final distress position recorded on the night of the disaster. Search vessels crossed the Atlantic carrying sophisticated sonar equipment, carefully sweeping section after section of the seafloor. Every promising signal created a brief moment of excitement, only to end in disappointment when the object turned out to be an ordinary rock formation, geological feature, or unrelated debris. The Atlantic was proving to be far more complex than the flat, empty landscape many people imagined. Deep underwater, the seafloor rises into ridges, drops into valleys, and stretches across vast plains covered by layers of sediment. Every unusual shape could resemble something significant until examined more closely. Each false lead consumed valuable time, fuel, and financial resources, while reinforcing an uncomfortable truth. The available technology was improving, but the search methods themselves might still be wrong. Historians also faced their own limitations. Survivor testimonies, although invaluable, naturally reflected moments of confusion during an extraordinary night. Navigation records were remarkably detailed for their time, yet even small differences in position could translate into miles of uncertainty across the open ocean. Ocean currents, weather conditions, and the movement of floating debris added even more variables. Instead of narrowing the search, every piece of evidence seemed to expand the number of possibilities. Some experts began to question whether the wreck might never be found at all. Others argued that the search area remained far too large for any practical expedition. There was even concern that decades of underwater corrosion might have altered the wreck so dramatically that identifying it would become increasingly difficult with every passing year. Yet beneath the growing frustration, an important realization was quietly taking shape. Every unsuccessful expedition had been collecting information, even if it had not discovered the ship itself. Scientists were building increasingly detailed maps of the seafloor. Engineers were learning how underwater equipment behaved under extreme pressure. Navigation systems became more accurate with each mission. The search was gradually creating something far more valuable than isolated failures. It was creating experience. That experience revealed a pattern that many had overlooked. Nearly every expedition was concentrating on finding the ship itself, as though it had descended in a perfectly vertical path and settled intact onto the ocean floor. But history rarely leaves such simple evidence behind. Large disasters often scatter clues across surprisingly wide areas, creating trails that investigators on land have relied upon for generations. If that principle applied beneath the ocean as well, then perhaps explorers have been focusing on the wrong target from the very beginning. Instead of searching for one enormous object hidden in darkness, they might need to search for the smaller pieces that inevitably marked its final journey. It was a subtle change in perspective, almost deceptively simple, yet it challenged decades of conventional thinking. The greatest obstacle had never been the absence of technology alone. It had been the assumptions guiding where that technology was being used. Soon, one explorer would recognize that difference, and by changing a single question, he would transform one of history's longest and most elusive searches. The breakthrough did not begin with a new machine. It began with a different question. Among the scientists determined to solve the mystery was oceanographer Robert Ballard, a researcher whose career had been shaped by exploring places few people had ever seen. Unlike many who approached the search as a hunt for a single object, Ballard believed the ocean itself had to be understood first. Years of studying deep-sea geology and investigating sunken vessels had convinced him that the remains of a large ship would almost certainly leave behind more than a single point on the seafloor. If the vessel had broken apart during its descent, gravity and momentum would have scattered countless objects across the ocean floor, creating a debris field that stretched far beyond the main wreck. That idea seems almost obvious today, but at the time it represented a major shift in thinking. Previous expeditions had concentrated on locating the ship itself, searching for one enormous target hidden in an immense underwater landscape. Ballard proposed searching instead for the smaller clues leading toward that target. In many ways, it resembled the work of an experienced investigator. Rather than beginning with the final answer, he focused on the trail left behind. Every scattered object, no matter how ordinary it appeared, could reveal the direction towards something much larger waiting in the darkness. This approach demanded patience as much as technology. Ballard and his team relied on an advanced deep-sea camera system known as Argo, which could be towed above the seafloor while transmitting continuous images back to the research vessel. Instead of stopping repeatedly to examine isolated sonar readings, the system allowed researchers to observe long stretches of the ocean floor in remarkable detail. Hour after hour, the cameras moved silently across an environment few human beings had ever witnessed. The images revealed endless sediment, strange rock formations, occasional marine life, and vast empty spaces that seemed almost impossible to comprehend. The work required extraordinary concentration because the smallest unexpected object could become the first meaningful clue. Yet the mission itself carried additional complexity. Ballard's expedition was supported in part through cooperation with the United States Navy, which had separate objectives involving the investigation of 2 nuclear submarines lost during the Cold War. Only after completing those classified responsibilities could the remaining expedition time be devoted to the search for the famous passenger liner. That limited schedule left very little room for error. Every hour mattered. Every decision about where to search carried enormous weight. Instead of sweeping randomly across hundreds of square miles, Ballard trusted the logic behind the debris field theory. He reasoned that if the ship had broken apart before reaching the seafloor, smaller fragments would be easier to locate than the massive hull itself. Once the first scattered pieces appeared, they could guide explorers directly toward the larger remains. It was a strategy built not on hope but on observation, engineering, and decades of accumulated experience beneath the ocean. The difference was subtle, yet profound. The mission was no longer asking, "Where is the ship?" It was asking, "What path did the ship leave behind during its final descent?" That single change transformed one of history's greatest searches from an exercise in chance into a methodical investigation. Somewhere in the darkness below, the ocean still held its silence, but for the first time in 73 years, explorers were following the clues in a way that gave history its best opportunity to answer. For days, the monitors revealed little more than an endless landscape of fine sediment stretching into darkness. The camera system moved methodically across the seafloor, capturing image after image that looked almost identical to the last. Hours passed with nothing to suggest that history was about to change. Life aboard the research vessel settled into a rhythm of quiet concentration. Every photograph was examined carefully because everyone understood that success might begin with something so ordinary it could easily be overlooked. The ocean was offering no obvious answers, only patience. Then, during the early hours of September 1, 1985, something unusual appeared on the screen. It was not the outline of a massive passenger liner, nor the towering bow that generations had imagined discovering. Instead, the first unmistakable clue was far smaller. A large cylindrical boiler emerged from the darkness, resting alone on the seafloor. To someone unfamiliar with the Titanic, it might have looked like another forgotten piece of industrial machinery. But to Ballard and his team, it immediately stood out. The ship had carried a distinctive arrangement of boilers unlike those found on many other vessels of its era. There was little doubt that they were looking at something extraordinary. More importantly, the boiler confirmed that the theory had been correct. The debris field existed. If one piece had survived the descent, others would almost certainly be nearby. Excitement aboard the ship remained controlled, but it was impossible to ignore the significance of what had just appeared. Rather than celebrating immediately, the team continued following the scattered trail. One object led to another. Fragments of machinery, sections of metal, and additional evidence gradually emerged from the darkness, each one pointing in the same direction. The investigators resisted the temptation to declare victory too soon. Scientific discipline demanded certainty, and certainty would come only when the larger structure finally revealed itself. Then, after following the growing path of debris across the ocean floor, the cameras captured the image that would become one of the defining moments in the history of exploration. Rising slowly from the darkness was the bow of the great liner, remarkably recognizable despite the passage of 73 years beneath the Atlantic. Its massive anchor remained in place. Railings still traced the familiar shape seen in countless historical photographs. Marine life had claimed the steel, covering portions of the structure with delicate formations created by decades beneath the sea, yet the identity of the ship was unmistakable. The mystery that had challenged generations of explorers had finally given way to evidence. What made the discovery so remarkable was not simply that the wreck had been located. It was how it had been found. The success did not come from luck or chance. It resulted from abandoning assumptions, trusting physical evidence, and allowing the ocean itself to reveal the path. The debris field had become the guide that decades of direct searching had failed to provide. In that quiet control room, there were no dramatic speeches and no triumphant declarations echoing across the Atlantic. There was something far more powerful. There was the realization that history had just crossed an invisible line. A ship that had existed only through eyewitness accounts, documents, and memory had become a place once again. Yet even as the first images circled the world and headlines celebrated the achievement, another truth was beginning to emerge. Finding the wreck did not close the story. In many ways, it marked the beginning of an entirely new investigation, because the images resting on the seafloor immediately challenged ideas that had been accepted for generations and raised questions that no one had expected to ask. The first photographs answered one question, but they immediately challenged many others. For decades, historians had relied on survivor testimony, official investigations, and engineering analysis to reconstruct the final hours of the ship. Those sources remained invaluable, yet they were now joined by something entirely new. For the first time, researchers could compare historical records with physical evidence resting exactly where the disaster had unfolded. Almost immediately, one discovery stood above the rest. The wreck was not lying on the seafloor as one intact vessel. Instead, the bow and stern rested hundreds of yards apart, separated by an enormous debris field filled with thousands of scattered objects. This single observation transformed the discussion surrounding the sinking. Earlier investigations had debated whether the ship had broken apart before reaching the ocean floor or remained largely intact during its descent. Survivors had offered conflicting accounts, and experts had argued over the available evidence for decades. The wreck itself did not answer every question, but it confirmed that the vessel had separated into two major sections before both portions settled onto the seabed. That conclusion reshaped historical understanding and prompted engineers to revisit long-accepted theories about the structural forces acting on the ship during its final moments. The debris field proved equally important. Stretching across a wide section of the ocean floor, it contained everything from massive mechanical components to everyday personal belongings that had drifted downward during the sinking. Rather than existing as isolated artifacts, these objects formed a silent record of the ship's descent through the water. Their locations allowed investigators to study patterns that had never been available through written accounts alone. Each object became another piece of evidence, helping researchers better understand the sequence of events without replacing the testimony of those who had survived. At the same time, the condition of the wreck surprised many observers. Popular imagination had often pictured a relatively preserved vessel resting peacefully beneath the Atlantic. The reality was more complex. Decades of exposure to saltwater, immense pressure, ocean currents, and microscopic organisms had gradually altered the steel. Rust formations covered much of the structure, while delicate sections had weakened over time. The ocean had not frozen the ship in time. It had continued changing it every single day since 1912. This realization carried an important lesson. The wreck was not simply a historical monument. It was an active underwater environment shaped by natural processes that would eventually continue transforming what remained. Scientists from multiple disciplines suddenly found themselves studying the site together. Historians examined its relationship to written records. Marine biologists investigated organisms living on the steel. Engineers analyzed structural damage. Oceanographers studied sediment movement and environmental conditions. The discovery became far more than the successful conclusion of an exploration. It evolved into an ongoing scientific laboratory unlike any other. Perhaps most remarkably, the evidence demonstrated that history is rarely static. Even events investigated for generations can acquire entirely new meaning when fresh physical evidence emerges. The ship resting beneath the Atlantic did not rewrite every chapter of the story, nor did it settle every historical debate. Instead, it refined understanding, corrected certain assumptions, and encouraged researchers to ask more precise questions than ever before. In that sense, the greatest discovery was not simply the wreck itself. It was the realization that the ocean had preserved a remarkable archive, one capable of deepening humanity's understanding while also reminding us that some of history's most important answers often lead to even more thoughtful questions. As researchers returned to the site in the years that followed, the wreck gradually revealed another identity. It was no longer viewed simply as the remains of a famous passenger liner. It had become an underwater time capsule, preserving thousands of details from a world that disappeared in 1912. Every expedition expanded that understanding. Cameras documented dining room furnishings, sections of grand staircases, machinery that had once powered the largest passenger ship of its time, and countless personal belongings resting quietly across the seafloor. Shoes, luggage, dishes, bottles, eyeglasses, and handwritten objects all appeared exactly where the currents and gravity had carried them decades earlier. None of these discoveries told a complete story by themselves, but together they created an extraordinary historical record that no archive on land could ever fully duplicate. historians found themselves studying not only the ship's construction but also everyday life during the early 20th century. Engineers examined manufacturing techniques preserved beneath the Atlantic. Conservators developed entirely new methods for protecting artifacts recovered from extreme underwater environments. Marine biologists investigated unusual ecosystems that had formed around the steel structure, discovering colonies of microorganisms capable of slowly consuming the metal itself. The wreck had become a place where history, engineering, biology, chemistry, and oceanography unexpectedly converged. Yet the discovery also introduced questions that reached beyond science. Should artifacts be recovered for museums and research, allowing future generations to study them more closely? Or should everything remain untouched on the ocean floor, respecting the site as both a historical landmark and a place connected to one of history's most remembered maritime disasters? Thoughtful people reached different conclusions. Supporters of recovery argued that carefully preserved objects could educate millions while protecting important pieces of history from continued deterioration beneath the sea. Others believed that removing items from the wreck risked separating them from the context that gave them meaning. International agreements, legal disputes, and ethical discussions gradually shaped how future expeditions would approach the site. These debates demonstrated that the greatest challenges after the discovery were no longer technical. They were philosophical. How should humanity care for a place that belonged equally to history, science, and collective memory? At the same time, researchers observed another reality that could not be ignored. The wreck was changing continuously. Corrosion, ocean currents, and biological activity were slowly altering the structure year after year. Areas that appeared relatively stable during early expeditions showed visible changes during later visits. Scientists understood that the ship would not remain preserved forever. Like every human creation exposed to nature, it would continue its gradual transformation. That awareness added a quiet sense of urgency to every expedition. High-quality photographs, detailed maps, and three-dimensional imaging became increasingly important because they documented features that future researchers might never see in the same condition again. In many respects, preserving knowledge became just as significant as preserving physical objects. The site had evolved into something larger than a destination for exploration. It had become one of the world's most carefully studied underwater archaeological locations, offering new insights with every carefully planned mission. Yet despite all the advances in technology and decades of scientific observation, one reality remained unchanged. Even surrounded by thousands of artifacts and countless hours of recorded images, the ocean continued to guard parts of its story. Physical evidence could explain many things, but it could not answer every question about the decisions, experiences, and final moments that unfolded long before the wreck ever reached the seafloor. Those mysteries still waited beyond the reach of even the most remarkable discovery. Even after decades of research, the wreck has never provided every answer people hoped it would. That may seem surprising at first. Once the ship had finally been located, many believed the mystery was essentially over. In reality, the discovery marked the beginning of a new phase of investigation, one in which every confirmed fact was accompanied by new questions that physical evidence alone could not fully resolve. Some conclusions became stronger because they were supported by the wreck itself. The separation of the bow and stern, the extensive debris field, and the condition of major structural components all offered investigators valuable information that had been impossible to obtain before 1985. Yet history is rarely explained by physical evidence alone. Human decisions, individual experiences, and rapidly unfolding events often leave no permanent record behind. That is where the limits of archaeology become just as important as its discoveries. Consider the testimony of survivors. Their accounts remain among the most valuable historical sources available, but they do not always agree with one another. Some recalled hearing sounds that others never mentioned. Certain witnesses described the final moments differently depending on where they were, what they could see, and the extraordinary circumstances surrounding them. Historians do not view these differences as proof that someone was mistaken. Instead, They recognized that every eyewitness observed only a small part of an event unfolding across an enormous ship under conditions of darkness, confusion, and limited visibility. The wreck can confirm some details, but it cannot recreate every personal experience from that night. Engineering studies have also continued to evolve. Since the discovery, researchers have combined historical records, metallurgical analysis, computer simulations, and direct observations from the wreck to better understand how the ship responded to the damage it sustained. These studies have refined earlier conclusions and improved scientific understanding, yet specialists continue to debate specific details regarding the sequence of structural failure and the precise timing of individual events. The available evidence supports many broad conclusions, while leaving room for careful discussion about finer points. That distinction is an essential part of responsible historical research. There are also questions that may never receive complete answers. What conversations took place during the final minutes that no one survived to record? Which personal choices changed individual lives in ways history can no longer trace? How many moments of courage, uncertainty, hope, or quiet determination disappeared forever beneath the Atlantic without leaving written evidence behind? These are not questions that sonar, cameras, or underwater vehicles can answer. They belong to the human dimension of history, where evidence becomes increasingly limited with the passage of time. Perhaps the most important lesson is that responsible investigation requires accepting uncertainty when certainty is impossible. The discovery provided facts. Scientific analysis supplied evidence. Survivor testimony preserved personal perspectives. Together, these sources create the clearest picture historians have ever assembled, yet none of them eliminates every unknown. Instead, they remind us that understanding the past depends upon balancing physical evidence with documented records while recognizing the boundaries of both. In the end, the greatest achievement was not proving that every mystery had been solved. It was demonstrating that careful investigation could replace speculation with evidence, while also acknowledging that some chapters of history remain unfinished. That balance between discovery and uncertainty is precisely what continues to make this story one of the most compelling investigations ever carried out beneath the sea. The true significance of this discovery cannot be measured simply by the coordinates recorded on a navigation chart or by the first images transmitted from the ocean floor. Its greatest impact reached far beyond a single ship resting beneath the North Atlantic. It fundamentally changed how humanity explores the deep ocean, investigates historical events, and understands the relationship between memory and evidence. Before the wreck was located, many believed that the deepest parts of the ocean would remain beyond meaningful investigation for generations. The success of the expedition demonstrated something entirely different. It proved that careful planning, scientific collaboration, and advances in technology could overcome challenges once considered impossible. In the years that followed, techniques refined during this search influenced countless other deep-sea expeditions. Researchers mapped previously unexplored underwater landscapes, located additional historic shipwrecks, examined geological formations, and expanded scientific knowledge of one of Earth's least understood environments. The legacy of the mission extended well beyond maritime history. It helped establish new standards for underwater archaeology, encouraging investigators to document sites systematically before disturbing them and to treat submerged cultural heritage with the same respect given to important archaeological locations on land. The discovery also reminded historians of an enduring principle. Written records, eyewitness testimony, engineering analysis, and physical evidence are not competing versions of history. They are complementary sources that become strongest when examined together. No single document could have revealed everything preserved on the seafloor, just as the wreck itself could never explain every human decision made during that night. Only by combining multiple forms of evidence could researchers approach a fuller understanding of the past. That balanced approach continues to shape historical investigation today. Perhaps the most remarkable outcome, however, was not scientific at all. It was philosophical. For 73 years, the missing ship existed largely in memory, literature, photographs, and personal testimony. Once the wreck was found, it became possible to connect those memories with a real physical place. Yet rather than diminishing the story, that connection made it even more meaningful. The images from the ocean floor reminded the world that history is not an abstract collection of dates and facts. It is made tangible through places, objects, and evidence that survive long after events themselves have passed into memory. At the same time, the discovery encouraged humility. Even one of the most thoroughly investigated maritime disasters in history still contains unanswered questions. The ocean yielded extraordinary evidence, but it also reminded researchers that complete certainty is rarely attainable. Responsible investigation requires acknowledging both what can be demonstrated and what remains unknown. That willingness to accept uncertainty without abandoning the search for evidence is one of the defining strengths of historical scholarship. Looking back, it becomes clear that the greatest discovery was never simply the wreck itself. The expedition revealed something equally important about human curiosity. Generation after generation refused to accept that the story would remain unfinished. Scientists improved their instruments. Engineers developed new technologies. Historians preserved records. Explorers challenged long-accepted assumptions. Together, those efforts transformed an enduring mystery into one of the greatest achievements in the history of ocean exploration. Yet even today, as the Atlantic continues its slow work upon the steel resting nearly 2.5 miles below the surface, the site offers a quiet reminder that every discovery is also an invitation to ask better questions. Sometimes the most important thing we uncover is not the object we were searching for, but a deeper understanding of the world, of history, and of the enduring human desire to pursue the truth wherever the evidence may lead.